This is a continuation of lesson 3.2 on polynomial functions. I'm trying to make smaller videos with less content in each one. So continuing on, problem number 9, we have the function right here, and it says to use the leading coefficient test. So I have degree 4. Leading coefficient, which I will abbreviate sometimes as LC, is positive because there is an implied 1 right up here. That tells me that the end behaviors are up and up. And I expect this to look a little bit like a W possibly. So rises to the left and rises to the right. I'm supposed to find the x-intercept, so let's go to the graph. To the y equals, and whoops, I think I'll just clear this out. This function is variable x raised to the 4th power, right arrow to get out of there, subtract 4 variable x raised to the 3rd power, get out of there, plus 4x squared. We actually could solve this and find the x-intercepts perhaps by factoring, because there is a greatest common factor of x squared, and then we can probably factor the rest. But if we just go ahead and do a zoom 6, all right. If you want to, you could zoom in on this a little bit right in here, but there is an x-intercept at 0. There is an x-intercept at 2. You can see that it is touching and bouncing away, touching and bouncing away. Let's, oops, I'm sorry, pull that back up. Let's drag it over here, and I will look at it as I need to. The x-intercepts that cross, none of them cross, I'm sorry, on this one, on the x-intercept, state whether it crosses, all right, crossing, well, the x-intercepts occurs only at 0 and at 2. The ones that cross, there are none. This never passes through the x-axis. The ones that touch and turn around, that's both of them, 0 and 2. If you had this graphed, it would look like y, or f of x, is equal to x squared times x squared minus 4x plus 4, which means it would be x squared times x minus 2 quantity squared. This represents an x equals 0, and it's a multiplicity 2. That means it touches. This one gives us x equals 2, but it's multiplicity 2, so it touches. Y-intercept, the y-intercept is 0 also. Let's see. Although this is a symmetrical shape, it is not symmetrical about either the y-axis or the origin, so this has no symmetry. What does the picture look like? It looks like choice A. Your grapher can be very helpful. Let's look at number 10. Now, number 10 in my math lab, you will click on one of these and drag it to the right position for 15, 16, 17, and 18. Oh, yes. But that's not really the numbering of the problem. So we're going to just do the leading coefficient test on this. This looks just like a nice third degree polynomial function. So we're going to have an x to the third. It goes down on the left and up on the right, so it's going to have a positive LC. This one looks like an x to the fourth, but it is down, down, so it has a negative leading coefficient. This one looks like a third degree, but it's reversed. It's up and down, so that means it's going to have a negative leading coefficient. And this last one, it's up and up, which the way that looks, it looks like an x squared with a positive leading coefficient. So let's see. This one, fourth degree, negative leading coefficient. This one goes right here. This one, third degree, positive leading coefficient. This one goes right here. This is just an x squared with multiplicity of the 0, and sure enough, that's what that shows. So this one goes here. This one is third degree, leading coefficient negative. This one goes right here. So use those in behaviors and whether it is positive or negative leading coefficient. Right? Now on this one, we're not going to graph it. We're just going to talk about in behaviors. Seventh degree, that's odd. If A, well, I sometimes call it A, it's also the leading coefficient. If that is positive and it's odd, then it is down, up. And you just need to remember that, although it is in your formula packet. So falls to the left, rises to the right. Number 12. Find the zeros, state whether it crosses or touches. All right, this polynomial function is in factored form. The zeros from this factor, you're going to get x is negative 8. From this factor, you're going to get x is negative 1. Now, this one is multiplicity 1. This one is multiplicity 2. This is a constant, and it does not affect this at all. Okay, there is 1 0. The multiplicity of the 0 is, no, there's not 1 0, there are 2 zeros. There are 2 zeros. The multiplicity of the smallest, now the smallest, negative 8, is smaller than negative 1. The multiplicity of that is 1. And the multiplicity of the larger 0 is 2. It didn't ask what the zeros were down here, it just talks about their multiplicity. And please notice that negative 8 is smaller than negative 1. In behavior, determine the behavior of the function at the zeros. Does it cross at all of them? No. It crosses where the multiplicity is 1. It touches and bounces away at multiplicity 2. So it doesn't do all of this. It doesn't always do this, but choice C, it crosses at odd multiplicity, x equal negative 8, and touches the x-axis and turns around at, up here, x equals negative 1. All right, next one. These are, we don't need to use our graphers when these are in factored form. All right, for this one, x equals 1, multiplicity 1, x equals negative 9, multiplicity 3. This one, it goes through. This one, it goes through. This one, it just lingers and wiggles a little bit before it goes through. All right, the zeros are positive 1 and negative 9. And There are only two zeros. The multiplicity of the largest zero, that's the 1, is 1. The multiplicity of the smallest zero, which is negative 9 is smaller than positive 1, is 3. And so what's going to go on? It's going to go through here and it's going to go through here. It crosses at all of the zeros. Goes through. All right, number 14. Excuse me, I thought I had paused the video, but instead I just coughed in your ears. So sorry. All right, find the zeros here. Now I can use my grapher. I think this time I will go ahead and find the zeros. 0 is equal to x to the third minus 40x squared plus 400x. So 0 is equal to x times x squared minus 40x plus 100. So let's go a little bit further. X times that's a 400. So x minus 20, x minus 20. So a slightly better way to write this would be x times x minus 20 squared. That means that I'm going to get x equals 0, multiplicity 1, and I'm going to get x equals 20, multiplicity 2. Certainly you could have used the y equals and graphed it. I just thought I would do this one differently. So I have 0 and 20. And let's see, there are two zeros. Yes, there are. The multiplicity of the smallest zero, which is 0, is 1. The multiplicity of the largest zero, which is 20, is 2. And the behaviors, okay, let's go back up. The original third degree, which is odd degree, positive leading coefficient, it's going to be down, up, and that was not the question. I'm so sorry, I just decided to talk about that, but it was not the end behaviors of the functions, it was the behavior of the functions at each zero, so I need to read a little more carefully. So since 1 had a multiplicity of 1, it crosses there, that is at 0, and it touches and turns around at 20. That was choice B. So I'm sorry about going off and thinking they were going to ask me about end behaviors when they were not. Number 15. They show the graph, and you can mimic that on your grapher if you want to. Okay, you could well, I don't see the function, so maybe you couldn't. All right, it says list the zeros whose multiplicity is even. Okay, here is a 0. That appears to occur at negative 3. Here's a 0. That appears to occur at 1. Here is a 0, and that occurs at 5. All of them are passing through. So there are no zeros with even multiplicities because those would touch and bounce away. Multiplicities that are odd, negative 3 has an odd, 1 has an odd, and 5 has an odd. Then it says to write an equation expressed as the product of factors. All right, if x equals negative 3 is a 0 or a root, then x plus 3 is a factor. If x equals 1 is a 0, x minus 1 is a factor. If x equals 5 is a 0, a root or an x-intercept, x minus 5 is the factor. It does not matter about the order, but these are x plus 3 times x minus 1 times x minus 5. And the y-intercept is actually the product of all the constants. So it is 3 times negative 1 is negative 3 times negative 5 is 15. Okay, so I got that by multiplying 3 times negative 1 times negative 5. All right, let's look at 16. See if we can see the answers. So this is 1, 2. This is a root of negative 3, and it has got multiplicity 1. But this one, 1, 2, 3, which is positive 3, and it looks like it has multiplicity 2 because it is just touching and then bouncing away. All right, multiplicity that's even, that will be just positive 3. And so that was even. Odd, that will be negative 3. Write an equation. All right, when I do this, and I know that x equals negative 3 has multiplicity 1, that's going to be the factor x plus 3. When I have x equals 3, but I know it's multiplicity 2, it's going to be x minus 3, but the multiplicity tells me that it has an exponent of 2. So that will be x plus 3 times x minus 3 quantity squared. What will be the y-intercept? I'm going to multiply the constants. 3 times negative 3 squared, which is 3 times 9, or 27. All right, let's look at this graph. Scoot it up a little bit more. All right. Now, this graph, this is going from negative 6 to 6, but it is going from negative 180 up to 10. So this right here is the second line there is the x-axis. So all of this is showing up below the x-axis, simply touching here at at negative 3, but that must mean a multiplicity of 2. Here is positive 1, 2, 3, 4. It also is a multiplicity of 2. Even multiplicities, that's all of them. Negative 3, positive 4. That was even multiplicity. Odd multiplicities, there are none. What will this be in factored form? Okay, at negative 3, when x equals negative 3, I'm going to get the factor x plus 3 because it's multiplicity 2. I'm going to have it squared. I have x equals positive 4, so I'm going to get the factor x minus 4, multiplicity 2. So this is, again, open something, sorry. This is x plus 3 squared times x minus 4 squared. How to find the y-intercept? It's going to be 3 squared times negative 4 squared, which is 9 times 16, or 144. All right. I think we are on finally our last question. Find the zeros and state the multiplicity of each, write an equation, and so on. All right. This appears to be x equals 1, negative 1, I'm sorry. Now, the multiplicity, it goes through, but it does not go through smoothly. You can see a wiggle through. We've not had one of those before, but there is an odd multiplicity, but it is not multiplicity 1, it is multiplicity 3 because of that wiggle. Here at 1, we have multiplicity 1, and here at 2, we have multiplicity 2. So list the zeros whose multiplicity is even. It looks like that will only be 2. List the zeros with multiplicity that's odd. That will be negative 1 and positive 1. Then it wants this in factored form. All right, going up here. If x equals negative 1, but the multiplicity, because of that curvature change, that's going to be x plus 1, but it will have to be to the third power. X equals 1. That gives me x minus 1, single multiplicity. And then x equals 2 is x minus 2, but it's multiplicity 2. So this will be x plus 1 cubed, x minus 1, x minus 2 squared. Let's check the degree of this. This is 3, 1 more makes 4, 2 more makes 6. If it has an even multiplicity, it makes sense for it to be up and up. The y-intercept, it is the product of the constants, so it is 1 to the third power times negative 1 times negative 2 squared. That's 1 times negative 1 times 4, which is negative 4. The only thing that I think might deserve a little clarity, if you're talking about multiplicities, suppose you had what if we were looking at y equals x plus 1? All right, if it has a single multiplicity, and that would be at negative 1, it's just going to pass through it. Even if it was x plus 1 times x minus 4. There's minus 1. There's 4. Single passes through smoothly. But if you had y equals x plus 1 cubed times x minus 4. 1, 2, 3, 4. If its multiplicity is odd, it means it passes through, but if it is 3 instead of just 1, it's going to come down and make a wiggle through there, changing its curvature, and then come back up, and I don't know how far down it would go, but can you see the difference between that and that? This means increased multiplicity. When you're talking about even multiplicities, like y equals x plus 1 squared, all right, then here it's going to come down, touch it, and bounce away. But if you had y equals x plus 1 to the 4th, it's going to come down and not make a turn, but it's going to come down and flatten out before it goes back up. It's not touching the x-axis all along there, but it's very close. So hopefully you can see the difference between that and that, just as much as you could see multiplicity 1 versus multiplicity 3. All right, hope polynomial functions make a little more sense. We will continue in our next section.